My name is Nawrocki. I'm a software developer. I work at NCBI, where I've been since 2015. From 2004 till 2015, I worked with Sean Eddy. And that's my main connection to Rfam is with Sean, I helped develop Infernal, which is the software package that is kind of the software engine underneath Rfam. It's used to do the RNA homology searches for each family that Rfam does for each release. It's also used to build the covariance model, each family's covariance model, which can be downloaded from the database and used by external users. I've also written some code that wraps Infernal that Rfam curators use. And I've had the pleasure, I believe, of working with all 5 Rfam leads. So Sam, Paul, Sarah, Anton, and now Blake. And I've had the pleasure of working with Alex Bateman for more than 15 years. So I didn't work with Sean until 2004, which was after Rfam had started. I'm not entirely sure what the initial vision was. My understanding is that it was to make a database like PFAM, but for RNAs. At the time, I'm not sure if there were any other RNA family databases, so there's definitely a void there, and I'm sure that was part of the motivation of getting Rfam off the ground. The biggest challenge we had in developing Infernal and what we really dedicated ourselves to wasn't making it more efficient so it could be fast enough to be used by Rfam for the large scale searches that it did. Prior to 2015, Infernal was too slow to do that, and Rfam used blast-based filters to make it fast enough. But in 2015, we made a release of Infernal that was fast enough, using its own types of filters, profile HMM-based filters. And that was a longstanding goal. And the reason that we wanted to do that is we thought the blast filters were causing the searches to miss some real RNAs, and we found out that that was the case. So the searches are now more sensitive than they were before when they were using blast-based filters. So one thing that's really striking is the number of families, the growth in the number of families. And that's been thanks to a lot of hard work by a lot of different Rfam curators. Another thing is when we were developing Infernal, we weren't sure if we could make the types of improvements that would allow the searches without the blast filters, but also to allow some of the most important families to have models. So the large subunit ribosomal RNA and small subunit ribosomal RNA were too long for there to be covariance models that could be efficiently used by Rfam. But Sean and I were able to build on related work by colleagues such as Zascha Weinberg and Michael Brown from David Hauser's lab, to build on that and their work and eventually make Infernal fast enough to have those ribosomal RNA models, full length ones in Rfam. So I think it'll continue to grow in terms of number of families. There's always new families being discovered. And I wouldn't be too surprised if the covariance model technology was supplanted by some other approach, possibly based on deep learning. There seem to be a lot of people that think that most sequence analysis problems are going to be, the best performing methods are going to be deep learning based in the coming years. But even if that happens, it won't change much. I don't think at Rfam, the curator's job will be similar. It'll just be a different underlying technology. I'd also really like to see more integration with other databases, although there has been a lot of that, integrating Rfam data into other databases recently. There's some databases where it could be really improved, in particular NCBI where I work. And so I'd love to see that improve over the next 20 years.